Greetings and welcome. In this session, we will discuss about the numerical method, that is how to solve the numerical on two-stage compression system with flash intercooling method. Now, we have seen in a theory how to use different formulas. For that, we need the pH diagram and construction. So, just a brief, here are the about 7 points. So for the 7 points which we have to plot on the cycle, that is this is called as vapor compression cycle, we plot on the pH diagram. So here for the different points we have to plot. So for this we have to have first of all numerical statement. So let us see numerical statement. So here in the numerical statement, here what is given: two-stage compression refrigerant system with flash intercooler having capacity of 30 TR. 30 TR is a cooling capacity of the system, which is used to achieve a minimum temperature of minus 20 degrees Celsius. Minus 20 degrees Celsius is the temperature at the evaporator. That is a point number 1, entry point of the compressor 1 or exit point of the evaporator. System uses R22 refrigerant, means we have to use R22 chart for getting the enthalpies. When the ambient temperature is of 40 degrees Celsius, ambient temperature means condenser side temperature. Here will be the condensation exit point, condenser exit point on the chart. Then some part of the refrigerant is expanded up to intermediate pressure of 5 bar, means here flash tank, that intermediate device. So that intermediate pressure line, that is will be at 5 bar. Assuming that the refrigerant entering to each compressor is a dry means here condition of compressor LP, low pressure, that is point number 1, and condition of vapor, that is passing to the next compressor, that is point number 3. So here these both points will be dry saturated. Then liquid refrigerant leaving the condenser, means after the condenser what point will come there? That point will be on the saturated liquid line. Compression in each compressor is isentropic, that is ideal process. For the simplicity of the problem and the solution, we use this statement. We are asked to calculate mass flow rate in each cylinder, power and COP of the system. So now let us see, first of all, plotting this on the chart. So here we have plotted as per the data given. Point number 1, that is the evaporator line, temperature is minus 20 degrees Celsius, point number located. This is a condenser, temperature, ambient temperature 40 degrees Celsius is given. So at 40 degrees Celsius on a saturated liquid line, here will be point number 5, that is a condenser line. When we get these 2 points, then we draw the horizontal lines, vertical lines, here horizontal lines. Again intermediate pressure is given, that is of 5 bar. So with reference of this 5 bar, this will be intermediate pressure line. Now all these values or all these process, what we do, that is what on the diagram, pH diagram of R22, because it is suggested in the numerical to use the refrigerant R22. So by plotting this much, we get the enthalpy of point number 1, then this point number 3, and here point number 5. As in theory we have seen that both expansion, means expansion in upper envelope of high pressure compressor and lower envelope of low pressure compressor, both are coming on the same line. That is why enthalpy of point number 5, 6 and 7, all enthalpies will be same. So it is coming about 250 kilojoule per kg. Point number 1, this enthalpy, point number 3 enthalpy. This we will get and we will write in the numerical. Now we will follow the same process what we followed in the plotting 1-2 line. This is isentropic line, isentropic process which should be parallel to the isentropic lines. So with help of the isentropic lines, we can draw a line from point number 1 which will meet or intersect to this intermediate pressure line, and we will find the point number 2. Similarly, point number 3 on the saturated curve, from that we will follow the same process and we will find the point number 4 where this second compression isentropic line will meet to this condenser line. somewhere, that is point number 4. So in this way all the points we located on the chart, and from the chart then all the points when we will drop on the scale at the bottom, then we will find the enthalpies, and these enthalpies now we will use in the numerical to solve and calculate the performance parameters. So first of all we have enlisted all the enthalpies which we have obtained from the chart. Here are the given data: evaporator temperature, condenser temperature, intermediate pressure, and cooling capacity. Now the first is what? To find the mass flow rate of the low pressure compressor M1 dot. Formula is what? Cooling capacity, TR is given, multiply it by 3.517 to get or to convert TR into kilowatt, divided by H1 minus S7. This is a enthalpy difference across the evaporation process. So putting the value of enthalpy 1 and 7 from this data, doing this calculation, we find value of mass flow rate low pressure compressor C1, that is M1 dot here in kilogram per second. Now to find the M2 dot, as we have seen or studied in a last video session, that is a theory part of this session, intercooling method. This is a formula. About this formula we have discussed. This formula is what? Energy balance, heat balance, which we use there. So from this we get this formula. So in this formula, M1 dot H2 plus M2 dot S6 minus M1 dot S6 is equal to M2 dot S3. So here M1 dot is a common, so you can take on the one side, M2 dot is another side. Here by putting the value of M1 dot and enthalpies, here we do the simplification for solving or for getting the answer. We do some simplification in this equation, and by putting all the values, unknown is what? Mass flow rate of the compressor 2 M2 dot, that we find in a kilogram per second. Then we find the compressor consumptions for compressor 1 W1 dot, that is a formula M1 dot into across first compressor enthalpy difference, that is H2 minus H1, H2 minus H1. So this we calculate in a kilowatt. W dot, that is equal to mass flow rate M2 dot, this we use here in the calculation, and enthalpy difference across the high pressure compressor. So high pressure compressor means point number 4 and 3. So H4 minus S3, H4 minus S3 values. So do the calculation, we find this value. Then we take the total power which is required to drive the system, that will be what? Summation of these two. So summation of these two, that is coming here about this value. Okay, so COP is again what? Output, that is a cooling effect in a TR, that converted into kilowatt, divided by sum of these two powers consumptions, work consumptions of both compressors. Then we find the COP. So in this way we got here mass flow rate of the both cylinders, that is compressor 1 and compressor 2. Here mass flow rate of the compressor 1, mass flow rate of the compressor 2. Here consumption of first compressor, second compression, sum of these two, that is a power to drive the system, and COP of the system. So in this way we can solve the numerical on intercooling method. So in this way we will solve the numerical, and let us meet in the next video session for the next method of the multi-pressure system.